What if I told you that everything that has ever happened or ever will happen, from a star being born to, I don't know, you just making a cup of coffee, is all governed by just two incredibly simple physical laws? And these aren't just suggestions. They are the universe's ultimate rule book, and they define the absolute limits of what is possible.
Okay, so let's just jump right in with a question that sounds, well, impossible. How could you possibly cook something in freezing weather without spending a single dime or a single joule on fuel? It sounds like some kind of magic trick, right? But the answer is actually hidden inside these fundamental rules. We'll definitely come back to this, but first, we got to understand the science that even makes a question like this possible. And that science is thermodynamics. Look, forget the complex formulas for just a moment and think of it as the science of the possible. It's basically a set of principles that dictates how energy and, believe it or not, even information can move and change. It doesn't tell you how to build something, but it tells you with absolute certainty what you cannot build. It's the ultimate reality check from the universe.
So here's our game plan. We're going to break down the two big rules of the universe in a way that'll really stick. Then we'll see them in action all around us, from your kitchen to the really mind-bending world of information itself. And by the end, you'll see how this knowledge is kind of like gaining a new superpower. All right, let's get into it. It all starts with Rule 1, which is simple and, well, pretty unforgiving. You can't win. This is the first law of thermodynamics. At its heart, this law is really just a simple accounting equation. All it says is that for any system, all the energy that goes out, whether it's as heat or as useful work, has to be perfectly balanced by all the energy that comes in. You just can't create energy out of thin air. To put it another way, you can't get something for nothing. The first law is all about the conservation of energy. You can change it, say, from the chemical energy in gasoline into the kinetic energy that moves your car, but you can never, ever end up with more energy than you started with. You can only move it around. Now, this leads to some really surprising limitations. Take a car engine, for instance. We put fuel in, we get motion out. Simple enough. But how much of that fuel's energy can we actually turn into useful work? I mean, what's the absolute theoretical maximum efficiency we could ever hope for? Is it 90%, 80%? Let's look at the numbers for a typical engine. The really crucial data points are the temperature right where the combustion happens. That's our hot temperature at 429 Kelvin, which is just a scientific scale, and the temperature of the exhaust as it leaves the system, which is about 300 Kelvin, so a little warmer than room temperature. So the maximum possible efficiency, something called the Carnot limit, is only 30%. That's it. This means that even a perfectly designed engine, one with zero friction, zero flaws, is still forced to waste 70% of the fuel's energy as useless heat. It's not a design flaw, it's just the law. You simply can't win. But as restrictive as that first rule is, it actually gets worse. Because not only can you not win, Rule 2 says you can't even break even. This is the famous and pretty often misunderstood second law of thermodynamics. Okay, the formal definition can look a bit strange. It uses this term called surprisal, which is really just a clever way of measuring uncertainty or disorder. All this law is saying is that the total amount of uncertainty in the entire universe can only go up or, at the absolute best, stay the same. It never, ever goes down. So the crucial point is this. Every single time something happens, literally anything at all, the universe as a whole gets a little bit messier, a tiny bit more disordered. The technical term for this is entropy, but uncertainty really captures the idea perfectly. It's a one-way street, always heading towards more disorder. Let's make this more concrete. Just imagine a hot cup of coffee. All that heat energy is nicely concentrated right there in the mug. That's a state of low uncertainty or low entropy. But what happens? Well, the heat naturally flows. It leaks out into the cooler room around it. And eventually, you're left with a lukewarm cup of coffee and a very slightly warmer room. The energy is now all spread out. The total uncertainty has increased. And you will never see the heat from the room spontaneously gather itself up and jump back into your cup. That would violate the second law. Okay, so now we have two incredibly powerful rules. But how do they actually work together? Well, the answer is probably humming away in your own kitchen. So here's our next puzzle. Your freezer uses electricity to keep things cold.
For every single joule of energy that you put in to run it, what's the absolute maximum amount of heat it can pump out? Do you think it's 1-to-1, maybe less, or could it be more?
The answer is a stunning 9.9 joules. That's right. For every 1 joule of energy you pay for on your electricity bill, your freezer has the potential to move almost 10 times that amount of energy in the form of heat. It's not creating energy. That would violate the first law. It's just using that 1 joule of high-quality electrical energy to pump a much larger amount of low-quality heat out of the freezer. And this reveals something that trips a lot of people up. A refrigerator and a heat pump are the exact same machine. They just have a different goal. A fridge's job is to keep the inside cold by dumping heat into your kitchen. A heat pump's job is to keep the inside warm by grabbing heat from the cold outdoors and dumping it into your house. They're both just heat movers, running on the exact same principles.
Now, this is where things take a giant leap into the abstract. What if I told you that these laws about heat and engines also govern something as non-physical as information and thought? Consider this. Your computer's memory is full of ones and zeros. Erasing that memory means wiping it clean, resetting it. That act of erasing information, of reducing the uncertainty inside your computer's memory, must, according to that second law, increase the uncertainty somewhere else. And that costs energy. So, what is the absolute minimum price tag?
Well, the physical limit is something called Landauer's principle, and it's about 1/40th of an electron volt. It's a truly unbelievably minuscule amount of energy, way less than the energy of a single photon of light. But, and this is the crucial part, it's not zero. Nature demands a payment for creating order, even if that order is just flipping a bit in a computer. Information, it turns out, is physical.
Okay, now let's flip that idea on its head. If erasing information has a cost, then creating it or recording it must have a limit. Based on the number of calories a typical human eats, thermodynamics actually places a hard ceiling on how much information a person could possibly record in a single day, and that limit is less than 10 to the power of 21 gigabytes. I mean, it's an absurdly huge number, yes, but it is a finite number. Your very ability to observe the universe is fundamentally constrained by the laws of thermodynamics.
So, how does this all come together? Well, understanding these laws isn't just some academic exercise. It's really like gaining a superpower, a brand new lens to see the hidden rules that are governing the world all around you. So here's your toolkit. Rule 1, you can't win, energy is conserved. Rule 2, you can't even break even. The total messiness of the universe is always going up. And together, these laws don't just limit engines and refrigerators, they set the fundamental boundaries for biology, for computation, even for thought itself. They really do define what is and is not possible. And that just leaves us with one final fascinating question to think about. Thermodynamics reveals this profound yet simple rulebook that's been hiding in plain sight, governing everything from heat to information. So what other simple, invisible rules might be out there, shaping our universe in ways we haven't even begun to imagine? Oh, and as for cooking in the cold for free, well, now you know the secret isn't magic at all. It's just a heat pump, putting the universe's ultimate rulebook to work.